This is the day 7 video number 2 where I'm continuing on. We left off in the last video with you being responsible for answering these three. This is a 45, 45, 90 triangle. I know that because if both of these two sides are x, the two sides are congruent, and if those two sides are congruent, the two angles must be congruent, and if the two angles are congruent and this one's 90, then these two have to add to 90 as well. This side that's the hypotenuse is the a radical 3 side. My job is to find the x value, which is the a side. To do that, I'm going to divide by radical 3. So I end up with a is equal to 12 divided by radical 3. We know we're not allowed to leave a radical in the denominator of a fraction, so I need to go through and rationalize, which gives me a final answer of 4 radical 3. For question E, 7 radical 2 is the side of A. I'm asked to find x, which is the a radical 2 side. If A is 7 radical 2 and I'm multiplying by radical 2, I end up with 7 times 2, which is 14 for that value of x. In question F, this is the side that's across from the right angle. This is the a radical 2 side, which means that when I divide, I get that a is equal to 5. Therefore, the x value is equal to 5 as well. When we turn the page, we're going to talk about another kind of special right triangle, and that's the 30, 60, 90 right triangle. And we're going to start by talking about an equilateral triangle where we know that each of the angles is going to be 60. If all three sides are the same, so are all three angles. We're going to draw in the angle bisector, which, when drawn into an equilateral triangle, not only becomes the angle bisector, but it also becomes the median, which means that these two parts are equal to each other, and it also is an altitude, meaning this is a right angle. So if I put my focus now on this right triangle that's right here, that right triangle is a 30, 60, 90 right triangle. The rule for the 30, 60, 90 right triangle, which I'm going to write down here, is that if you have a 30-degree angle, a 60-degree angle, and a 90-degree angle, whatever side is across from the 30, let's call it A, the side across from the 90 must be 2A, and the side across from the 60 must be A radical 3. So if I'm giving you an example of this, it would be an example where you know that you have a 30-degree angle, a 90-degree angle, and a 60-degree angle, and I'm telling you that this side over here is 7. Now, according to my diagram, across from the 30 is the side of A, so this is the A. That's the side we really want to find first, so that we can do 2A for the side across from the 90, and do A radical 3, which would be 7 radical 3, for the side across from the 60. If I take a look at the examples at the bottom of this paper, I usually try to fill in the missing angles. It's a good reminder to me. Technically, the side across from the 90 is the 2A side, which means that A is 5. The side of A is across from the 30, so that's 5. And the side across from the 60, the side of Y, is the A radical 3 side, so that's 5 radical 3. So it's your job to keep track of which value of A is across from which angle. Plain old A is across from the 30, A radical 3 is across from the 60, and 2A is across from the 90. In part B, across from the 30 is 21, that's my side of A, which means across from the 90 is my 2A side, which is 42. Across from the 60 is my A radical 3 side, which is 21 radical 3. So in these, if I was giving you a goal, I would tell you to always find the side of A first if it's not given. In part C, they tell me that the side across from the 60 is 15. I know that that is the A radical 3 side. which means I need to solve for a, so divide by radical 3. Not allowed to keep a radical in the denominator, so I need to rationalize. So I end up with a equals 15 radical 3 over 3, which is 5 radical 3. So my a value is 5 radical 3. That is the side that's across from the 30, and across from the 90 is 2a, which in this case is 2 times 5 radical 3, which gives me 10 radical 3. Part D is a word problem that it deals with this 30, 60, 90. They tell us that we have an equilateral triangle. That's kind of how we started this. We know that each of the angles, therefore, is going to be 60, because if all the sides are the same, so are all the angles. It tells me that the altitude that's drawn in is 7 radical 3. So if I am focusing just on this triangle, the yellow one right here, I know that this is a 90-degree angle here because it's an altitude, which leaves me 30 right here. So they are technically telling me that 7 radical 3 is the a radical 3 side, which means that a is 7. The side of a is here. The 2a side is here. They're asking me to find a side of the equilateral triangle. That would be this, could be this, could be this, but they want one of them. So I know that that side then is going to be 14. If you flip your paper over, there's a couple more problems that deal with the special right angles. In question E, it says that we have a rhombus with a 60-degree angle, and one of its sides measures 12. If I draw a rhombus, one of the things that I want to remember about the rhombus is that if one of the sides is 12, all the sides are 12. And it wants the length of both diagonals, so I'm going to draw both diagonals in here. And when I draw that diagonal in, one of the things that we talked about with respect to a rhombus is the diagonal bisects the angles. So that means that this is really 30. Diagonals in a rhombus are perpendicular, so that's a 90-degree angle, leaving me 60 for here. And if you went through and looked at any of the 4 triangles that you see in there, all 4 triangles are 30, 60, 90 triangles, with their 2a side, the one across from the right angle, being 12, which means that a is equal to 6. In my little 30, 60, 90 triangle here, across from the 30 is my side of a, which is 6. Across from the 60 is my side of a radical 3, which is 6 radical 3. So in this case, the shorter diagonal, which we'll call this one right here, is going to be 2 times that side of 6, because that's half. Diagonals bisect each other. And the longer diagonal, which I'll mark as this yellow one here, is going to be 2 times the 6 radical 3, which is 12 radical 3. The last 5 examples here are mixed practice with special right triangles, and I am going to do that in a separate video. So there will be a second video, third video actually, that goes with this day. This third video is required.